Good morning, all of you. And as on request, I'll solve some questions from the IIT Bombay maths mock test. तो यहाँ पे particularly जो toughest questions है और technical है उसको solve करेंगे and which was particularly useful for you JEE relevant and which was particular useful for JEE examinations. The second questions I'll do at the last क्योंकि telescopic series पे based है. Third question is very nice problem from the triagram. So one way of doing third problem is blindly you can find the points, 4 points, and then using 1 by third times area base into height we can find the volume. Okay, I think fourth question was the most technical and toughest one to think. Fifth question, as a hint you can try, it's from conic section. So the given equation can be written in the form of distance of a variable point x comma y from a fixed point and a fixed line is having some particular ratio which is known as eccentricity. So you can make perfect square and it can be written in that fashion, which again I'll do at last. Sixth question is very nice from Parabola, and I guess the first part of this question you must have done as a necessary and sufficient conditions from a point to have three normals. We also call it co-normal points. The second part of sixth question is to integrate and find the area, and third part is to find the minimum value of a plus 2 b plus 3c where a, b, c are natural numbers. So let's start with the toughest one, which is probably question 4. So question 4 mein how we go about it. So let's see how to think. So we need to find the value of limit n tends to infinity, this monstrous expression, and half identity to it. Now the first idea and motivation of doing this kind of problem is maybe somehow this summation can be written as integration of something dx, some function of x dx from hash to star. So maybe you'll be tempted to think like it can be casted in the fashion of limit as integral of sum. तो उसके लिए we must have r by n everywhere in picture or you should be able to produce r by n and 1 by n dx. अब यहाँ पे 1 by n दिख ही नहीं रहा है, so clearly ये idea drop करना होगा. Second idea which is very useful for JEE manipulation is टेलीस्कोपिक सीरीज. अब टेलीस्कोपिक का भी यहाँ पे बहुत ऑब्वियस हिंट इज नॉट देयर क्योंकि 2 का पावर 3r plus 1 if you need to separate this into two part the headache is the numerator because product of that expression will still not be like it can't be written as a difference of two sums. So now I am left with only ideas. So maybe it's not telescopic, it's not limit as integral of sum, तो या तो फिर सैंडविच थ्योरम भी हो सकता है, लेकिन सैंडविच थ्योरम में भी ये एक्सप्रेशन काफी कॉम्प्लिकेटेड आ रहा है. दूसरा हिंट है so might be since so for this we know we can write the generalized binomial theorem 1 plus nx to n minus 1 into n by 2 factorial plus n into n minus 1 n minus 2 by 3 factorial times x squared times x cube and so on so forth. So probably that idea might help us. अब the feeling of this third binomial expression idea is little bit intuitive here because we have r factorial in denominator, so that motivates 1 factorial, 2 factorial, 3 factorial, as well as we have product of some expressions. So let's, if you play with I equals 1 to let's say r if I keep 3, so we'll have I equal to 0 to 2, right? So we'll get values like 1 minus 0, 1 minus 2, 1 minus 4 and so on. So we'll get like 1 for I equals 0, and then we have minus 1 for 2, it's minus 3, for 3 it's minus 5, so 1 3 minus 5 minus 6, and that gives a feel of like some kind of continued products or at least some continued fraction. So यहाँ से the takeaway was final motivation is to somehow think of binomial expression. Again, it is on a toss because maybe that idea will work. तो इसके लिए we'll start on that ground, and as we can see from the problem is we have particularly two reoccurring in the expression. Okay, so first thing I'm going to do is to take 2 common. So given expression can be written as 2 to the power 3r plus 1 2r plus 1 times r factorial, and our motivation is somehow to bring like since 2r plus 1 is there in denominator, so I want to bring x to the power 2r plus 1 in numerator because this is integration of x to the power 2r dx. So somehow this can be linked with integral and we'll be able to sum it easily, right? So that's a very useful all India test series kind of problem solving skill. So now 2r plus 1 is already available. So let's try to get x to the power something. So clearly there is no terms like x. So I can define because of recurrence of 2. So let's call half as x. Because the reason is half to the power 3r plus 1 somehow I can drive on the numerator side to bring x to the power something, right? तो इस मोटिवेशन से मेरा क्या हो जाएगा, this can be written as half times half whole to the power 3r plus 1, बट वी वांट 2r plus 1, तो इसके लिए माइनस r कहीं ना कहीं आना होगा. अब यहाँ से आप देख सकते हो i equal to 0 to r minus 1 में r number of terms है, so that gives us motivation of taking 2 out. So 2 out करेंगे तो 2 का power r because 2 will be out in every terms, and we'll have half minus I, and this product running from I equals 0 to r minus 1, right, into minus 1 to the power r. So this expression can be written in that fashion, r equal to 1 to n, and clearly limit I have to take to infinity. So finally what we can see is if I see extra to the power r, so it can be written as half to the power 3r plus 1 into half to the power minus r to minus 1 to the power r, product of half minus I running from 0 to r minus 1 divided by 2r plus 1 times r factorial, summation running from 1 to n, limit n tends to infinity. Now that is a good news because 3r plus 1 and minus r will combine, and this will create sigma half to the power 2r plus 1 divided by 2r plus 1 in denominator. So this will engage with that structure. We have extra minus 1 to the power and then product half minus r I equals 0 to r minus 1 by r factorial. Remember, r is running from 1 to n and limit n is infinity. Because since r is constant, I am integrating only with respect to x, right? तो यहाँ पे minus 1 to the power r in this entire structure, product r minus 1 half minus I by r factorial will be treated as constant, and then sigma r equal to 1 to. Now unfortunately this does not feels very nice because finally we must get x is not a variable, right? So x is half, so I should get the expression like half to the power 2r plus 1 by 2r plus 1. So that motivates us to integrate this from 0 to half, because if I see 0 to half integral x to the power 2r dx, that will give me x to the power 2r plus 1 by 2r plus 1 evaluated from 0 to half, which is half to the power 2r plus 1 by 2r plus 1. So very interestingly, half to the power 2r plus 1 by 2r plus 1 can be written as 0 to half x to the power 2r dx. So hence this entire expression can be casted in the definite integration, right? And since r is changing from 1 to n and this function is continuous, hence I can swap the integration with sigma. So instead of limit n tends to infinity, what I'll do, first I will write integration and then I can keep on playing with that. So let's see, first you put r equals 1, then integrate r equals 2 and integrate and keep on doing so. So instead of that, first we'll do summation, we'll push it inside 1 to n x to the power 2r minus 1 to the power r, product of half minus I by r factorial, this entire dx. That seems cool because this expression can be written as minus x square to the power r, right? And same thing. See, what if I'll decode this? And clearly since we have limit n tends to infinity, so we have 0 to half, infinite such terms are here. So let's decode some of the term. Let's put r equal to 1, and the first term that you are getting is minus x square into half, right? What about second term? If I'll put r equal to 2 in this entire expression, so that will give you x4 times half, and till 2 it will go. So I0 will give half, I equals 1 will give minus half. R2 we make it go from I equals 0 to 1 divided by 2 factorial. Let's try one more. Third term. So we'll have minus x6 half, it will go till r minus 1 means 2 minus half to minus 3 by 2. I'm just decoding it just to get a feel of what exactly, where exactly is going, and so on till infinity. And now you can sense the structure of generalized binomial structure here. And now you can sense the structure of generalized binomial expression, because something and something minus 1 and something something minus 1 something minus 2, so 3 terms by 3 factorial and so on. What is missing over here is missing term is just one expression half, right? Now that's fine because this half was already outside. So if I'll add half plus this entire expression, so it can be just written as half inside heavily. That's directly follows from the initial expression over here. And now what is this binomial expression? It's nothing but root over 1 minus x square expansion of infinite series. So 0 to half this dx. Now this integral is quite easy because geometrically root over 1 minus x square represents this upper semicircle. And we are interested in area from 0 to half. So basically the area shown over here. Let's see if I connect this. It's area of the sector over here plus area of triangle. Right? Now since we have this distance half and the radius is 1, so it's cos 60 5 by 3, hence the angle at the sector theta sector is pi by 6. So we have answer as pi by 6 plus area of triangle half into base into height, so half into half into what about height, it is sine pi by 3, so root 3 by 2. The answer for this beautiful problem is root 3 by 8 plus pi by 6. If I'll go to question 2, that's not really hard because you must have done this question like root over 2 plus 2 in your school level as well. So what I'll do is we'll square it up. So r square n, remember is r is a function of n, so that's a symbol, it's not r into this, right, which can be the first sort of confusion. So r square n is n plus rn, and if I'll solve this quadratic, r square minus r minus n equals 0 plus 1 plus minus b square and minus 4ac 4ny 2. Since 1 plus 4n for any natural number will be more than 1, so negative sign is discarded. Hence the answer is Rn equals 1 plus square root 4n plus 1 by 2. Right, now what you can do is n into n plus 1, and this guy is Rn plus 1 into n plus 2. So simply we can plug that result. So let's find Rn into n plus 1. That will give 1 plus root over 4n square plus 4n plus 1 over 2. You can say that's perfect square, so just 1 plus 1 by 2. So that gives you n plus 1. What about r of replace n with n plus 1 times n plus 2? So we'll get just n plus 2 over here. So hence the given sum takes form of 2 by n plus 1 into n plus 2, and that's a usual telescope now, which can be written as just 1 by n plus 1 minus 1 by n plus 2, and the difference is 1 and 2 times of that, and it telescopes, and that telescopics to, let's put n equals 1, so half minus 1 by 3 plus n2 1 by 3 minus 1 by 4 and so on. So everything gets killed off, the answer simply evaluates 2. So this was a nice problem on the basic again. So this was a nice problem on the basic whose answer is 1. It is just a standard telescope. So I'll rate it easy to medium. The third one is really interesting one. You can find the point of intersection between these planes. And it's not that calculative because the planes are nice and symmetric. Okay, so what about PA1? So it's a, so what about V root 3 minus root 3 2 and 0? So it's a volume of the triangle formed by p root 3, p minus root 3, and then q2 and q0. So if you'll see that plane for minus z plus 2 equals half, and q0 is even, z equals minus half. So these are 4 planes, and these 4 planes we make a tetrahedron. We need to find the volume of it. So if we'll solve these planes, method 1 is we can solve both of them, and you can clearly see 0 0 and 3 by 2 is one of the point, because if I'll keep x0 y0 and z 3 by 2, it satisfy both of these equations, right? So that's a point, and 0 0 3 by 2 is clearly a point on the line joining these two planes. And also the third one. So if you'll see, if 3 plane intersects, 2 planes in general will intersect on a line, and if you have a third plane, so it will intersect at a point if it is not parallel to the line joining those 2 planes. So if we'll solve the first 3 equation, that's going to give a point A given by 0 0 3 by 2. Similarly, we can get point B 0 root 2 minus half, point C root 3 by 2 minus 1 by root 2 minus half. We have point D over here, minus root 3 by 2 minus 1 by root 2 minus half. Now given 4 points A, B, C, D, we can easily find the volume of this tetrahedron by defining AB, AC, and then AD, right? So AB and AC will give area of the base. AD, if I'll take the projection of point D, which is BD over this base triangle, I'll get its side. Or directly, since 3 sides, co-terminal sides of the tetrahedron is known, so volume will be 1/6 of AB minus root 3 by 2 minus 1 by root 2 and minus 2. So if I plug all these values over here, it's just about calculating the value of this determinant. That will get to be root 3. So that's a blind approach of doing this question, but you can do it using observation, and that was the sole purpose of giving this question. Okay, you can notice that all the planes is at equal distance from origin. Okay, it means if we have a sphere, so all these planes are basically tangential to this sphere, right? All these planes are tangential to this sphere, and hence they form a tetrahedron over here. So in that sense, we have to find the volume of tetrahedron which is formed there, because the distance from origin to all these planes, so from 0 0, first one is 3 by 2 by root over x square 6 plus y square 2 plus z square 1. So that's basically 3 by 2 by 3, which is half. Similarly, if you see distance from origin to z equal to minus half is half. Distance from origin to the third plane is half. From fourth plane and first plane, all is half. So all these planes are equal distance from origin. Also angle between any these two pairs. If we'll check the angle between, let's call this P1, P2, P3, P4. So angle between plane number 1 and plane number 2. What is that angle? So cos theta is, the vector is root 6, root 2, 1 dot minus root 6, root 2, 1 divided by its magnitude. That is 3 into 3, which is 9. So this guy is minus 6 plus 2 plus 1 by 9. Right? So minus 3 by 9. So of course, we are interested in acute angles. Acute angle is cos inverse 1 by 3. Similarly, if we'll check the second and third, the angle, the dot product is invariant. So it's same. First and third is same. So angle between any two pairs of this plane is cos inverse 1 by 3, right? So that gives a feel that because cos inverse 1 by 3, which means cos theta equals 1 by 3, is a very special angle. And that's giving a feel that it is forming a regular tetrahedron. So for side length, we just need to calculate 2 point of intersection. And as in the above, once we find any two point of intersection. So let's say we have found this point C over here, and by symmetricity point D over here, I know the side length of this triangle CD. So once you observe the angles are invariant, you can just find one side length, and that's enough to give you the volume of the triangle magnitude, and that's √6, and that is A, the side length of this triangle. Now volume can be written as 1 by 3 times area of base into height. Since area of base and height, which is standards, 1 by 3 into that's equilateral triangles, we have √3 by 4 into A square into √6 into √2 by 3, and that will give you √3 as your answer. Although there is another way of finding area of regular polygon. So since all these vectors A, B, C are equiangular, their angle are same. So hence if I know the side length, what you can write as B square is A dot A, A dot B, and hence the angle between any two sides in the regular tetrahedron will be 60 degree. So that's going to be A square, and this you can evaluate, and if you put A equals √6, you are going to get the same answer as √3. Now coming to question 5, as I've already given hint, you can make it a perfect square, which is not very difficult here, because if you see it's y square minus x square plus n square x square minus 10 n square x plus 25 n square, and this motivates you. We have y square plus x square equals nx whole square plus 5n whole square minus 2ab. So if you see 2ab, that will be minus 10 n square x. So that gives us nx plus 5x whole square minus 5x whole square. Now you take a square root on both sides. The square root of x square plus y square is, so this represents the distance of a variable point x comma y from origin, and x minus 5 represents distance from x equals 5. So the radius of distance is n. So n is eccentricity of over here. They have mentioned n is an integer, so n is in fact natural number. The question. So a car is also intersection, of course. So depending, now you can play with the value of n and see how much minimum fuel you need to move the corresponding path, and the path length of the curve is 1 plus dy y dx whole square dx. This is basically you need to integrate from the starting point to the final point, right? So that you can do, and you'll already get the answer which I've given in the key. So as a hint, we have given also the arc length over a curve is a sum of elementary arc lengths. The last question is interesting. So we have to find the locus of all points for the parabola y square equal to 4x, from which three distinct normals can be drawn. In fact, here it is. Last question is interesting because you have to find the area of region from where less than 3 normals can be drawn. So what we can do is we can find the region where maximum 3 normals or 3 distinct normals can be drawn, and entire region R2 coordinate plane minus that region will give the required area. So how to go about this? Now this is quite a simple problem which you are doing at JEE level as well. So we have y square equal to 4x, coming to question 6, and a general equation of normal to this parabola having slope m is mx minus 2m. So in this case a equals 1 minus m cube. Now this has to pass through, let's say, alpha beta. So all the normals which passes through alpha beta, I wanted 3 such normals. So 3 such values of slope to be more precise. So we'll have beta equals m alpha minus 2m minus m cube. Now this equation should give me 3 distinct real roots. So it's a cubic in m. Now for this cubic to give 3 distinct root, since we know if I define this to be a function f of m, so derivative of f dash m is going to be 3m square plus 2 minus alpha. And since at m tends to infinity, the function will go to infinity. M tends to minus infinity, will go to minus infinity because it's in point behavior. So the function has to do something like this to get 3 different answers. let's say m1, m2, m3. It means its derivative should die twice. Not only it should die twice, but f dash m should die, let's say, at 2 point alpha and beta. It should be such that the value of the function f at alpha and f at beta should have different nature. Since f alpha, clearly you can see from diagram, should be positive and f beta should be negative. So now that restrictions you have to keep over here. So here the roots that I am getting is 2m square equals alpha minus 2 implies m square is alpha minus 2 by 3. And that also shows the necessary condition for 3 normal should be alpha more than 2. That's why in any parabola, if alpha value, especially for y square equal to 4x, if alpha is more than 2, then that's a necessary condition to draw 3 normals. It's not sufficient, although like all the points in this region cannot give guaranteed 3 normals, but for 3 normals you must be in this region, right? So here I want to find the sufficient conditions as well, because for m to be real, alpha must be greater than 2, or in fact to be more precise, greater than equal to 2. But is that sufficient? No. Why? Because even we can have the situation of 3 normals to be completely above this position. So let's see how to go about this. If your necessary conditions is fine, but how to go about sufficient condition? So it's like you have to find the roots alpha and beta, and that will be m equals plus minus alpha minus 2 by 3. So if I call this root is sum over here, m alpha, and let's call it m beta. So now I need to put the value of this root in the given expression. So f of root over alpha minus 2 by 3 should be negative, because that's a positive value. That's a positive, you should get negative. And f of minus root over alpha minus 2 by 3 should be positive. Okay, so both these conditions should be satisfied. So intersection of both. And if we'll take these conditions, we'll get very and if we'll take these conditions, you'll get an interesting result, which will give you 3 root 3y to be more than 2 times x minus 2 to the power 3 by 2. This curves die at 2, and if we'll do exactly, we'll get curve like this. So now for any value of x, if y coordinate, and this will give you interesting result, this will be less than this. So from this region, if I'll draw any normal, I'll get exactly 3 distinct normals. So according to us, according to our problem, we need to find the area of the region here. Okay, so by symmetricity is just twice of area of this region over here. So what we can do is we'll integrate 0 to 8, x coordinate is going to be 8 over here, and y coordinate will be root 32. So once we find this, we'll get 0 to 8, 2 times of root x dx minus 2 to 8, and this area we need to subtract, take away 2 by 3 root 2, 3 root 3 x minus 2 to the power 3 by 2 dx, and this time 2, और इसका आप evaluate करोगे तो 352 root 2 by 50. And now you can play with the different cases, because 352 some factors you can put inside this square root to get different possibilities, right? So this is how you can track these questions. I hope you are enjoying this problem solving of very challenging nature, and usually this kind of questions आप coaching institute में भी नहीं देखते हैं. If you want more problem solving of this kind of sessions like this, thank you, have a good day, keep enjoying, keep watching.